When you look up at the night sky, it feels endless. Points of light shimmer across the darkness like scattered jewels, each one seemingly alone in an infinite sea. But what if every point you see, every speck, every faint shimmer, is not a star, but an entire galaxy? Each one a vast island of suns, worlds, gas and dark matter, floating in the silent ocean of space. Tonight, as you stand beneath the stars, you are not looking at a few thousand distant suns. You are looking at a fraction of the universe. The visible sky, even to the largest telescopes on Earth, is only a keyhole into a cosmic cathedral so vast it defies comprehension. Scientists estimate that the observable universe contains hundreds of billions of galaxies, maybe even trillions, each filled with billions of stars. But that is just the beginning of the mystery, because the question is not just how many galaxies there are. The real question is, how many are hidden beyond the edge of visibility? How many lie beyond the horizon of time itself, too far for their light to ever reach us? We live in a universe so immense that most of it will remain forever unseen. Light takes time to travel, and the farther we look, the deeper into the past we go, until we reach a wall, the edge of the observable universe, roughly 46 billion light-years away in every direction. Beyond that boundary, light has not yet had time to arrive. It is not that nothing exists there. It is that those galaxies are lost to us, hidden behind the limits of physics itself. That simple truth changes everything. We once believed the universe was a single collection of stars, our own galaxy, the Milky Way. But we were wrong. What we can see is only a small, glowing fragment of something infinitely greater. And the deeper we look, the stranger the story becomes. Because the universe is not just vast, it is layered, structured, and alive with motion. To understand how we reached this point, how we went from believing in one galaxy to discovering billions, we have to go back to the beginning of our cosmic awakening, to the moment when humanity first realized that the Milky Way was not the universe at all, but one of countless islands adrift in the dark. For most of human history, we believed the stars above were all there was. Ancient astronomers thought the Milky Way was the universe itself, a grand shining river of light circling everything that existed. Aristotle imagined the cosmos as a series of perfect crystal spheres, each carrying the sun, moon, and planets in harmonious motion. To the Greeks, Romans, Persians, and Chinese, the heavens were eternal, unchanging, divine. Even when telescopes arrived in the 17th century, that illusion held. Galileo saw that the Milky Way was made of uncountable stars, but he still thought all those stars belonged to one great cosmic system. The universe, as far as anyone could tell, ended at the edges of our own galaxy. For centuries, astronomers stared at faint blurry patches of light they called nebulae. Some, like the Orion Nebula, were gas clouds within the Milky Way. But others, spiral-shaped, distant, mysterious, did not fit. What were they? No one could agree. Were they star clusters inside our galaxy, or separate island universes, as the philosopher Immanuel Kant once imagined? The debate raged for decades, unresolved, until one man decided to measure the truth. In 1923, using the 100-inch Hooker telescope on Mount Wilson, a young astronomer named Edwin Hubble focused on one of those fuzzy spirals, the Andromeda Nebula. Through careful observation, he identified a Cepheid variable star, a rare kind whose brightness pulses in a predictable rhythm. By comparing its apparent brightness to its known luminosity, Hubble calculated its distance. The number he found changed everything. Andromeda was not a nearby cloud. It was more than 2 million light-years away, far outside the Milky Way. It was another galaxy. Overnight, the universe grew from one galaxy to billions. The cosmos was no longer a single city of stars, but a continent of galaxies stretching beyond imagination. The Milky Way, which once defined our cosmic home, became just one of countless islands in an infinite sea. The revelation was not only scientific, it was existential. For the first time, humanity understood its true insignificance. Our galaxy was not the center of creation. It was a small province in a much larger realm. And yet, there was beauty in that humility. Each discovery pushed us further from the illusion of centrality, but closer to the truth. We were part of something greater, an expanding universe filled with light, motion, and history. Hubble's discovery opened a door that could never be closed. When we looked through it, we saw not just new galaxies, but the unfolding story of the cosmos itself. From that moment on, astronomy would no longer ask, "What is out there?" but, "How far does it go?" Because now we knew our universe was far larger, older, and more mysterious than we had ever dared imagine. Once we realized that the Milky Way was not the entire universe, but merely one among billions, the next question came naturally. How many galaxies are there? Counting galaxies is not as simple as counting stars. They are scattered across unimaginable distances, their light weakened and stretched by time itself. To measure them, astronomers had to do something daring. Point their telescopes not at bright, obvious regions of the sky, but at empty space. In 1995, scientists using the Hubble Space Telescope selected a patch of sky so small it seemed absurd, no larger than the width of a grain of sand held at arm's length. For 10 days, they let Hubble stare into that darkness, gathering every photon it could. When the image finally came back, the results stunned the world. In what had looked like nothing, there were over 3,000 galaxies, each one different: spirals, ellipticals, irregulars, tiny islands of light shining from the early universe. That image became known as the Hubble Deep Field. It proved that the sky, no matter where you look, is crowded with galaxies. There are no true voids, only depths we have not yet reached. 10 years later, scientists repeated the experiment, this time with longer exposure and more advanced instruments. The result, the Hubble Ultra Deep Field, revealed 10,000 galaxies in an even smaller region. Each one existed at a different moment in time, their light taking billions of years to reach us. Some were young, chaotic, still forming stars. Others were ancient, their fires already fading. The image became a window into cosmic history, a record of creation itself. From those tiny windows of the sky, astronomers extrapolated the rest. If even the smallest dark patch hides thousands of galaxies, then across the entire celestial sphere, there must be at least 200 billion galaxies within the observable universe. And that number kept growing. When the James Webb Space Telescope launched, it peered even deeper, capturing galaxies that existed just a few 100 million years after the Big Bang, too faint for Hubble to see. Webb's first deep field revealed a universe far denser with galaxies than we had ever imagined. Some scientists now estimate the real number could exceed 2 trillion. 2 trillion galaxies, each with billions of stars, each with its own history, structure, and fate. Yet what is even more astonishing is that this is only the part of the universe we can see. Beyond that lies the unobservable, the regions too distant for their light ever to have reached us. The true number of galaxies may not be in the trillions, but in the quadrillions. Scattered across space, we will never access. The universe is not only vast, it is layered in mystery. We count galaxies not to reach a final number, but to confront the infinite. Each new image is not a map, but a mirror, showing us how little of existence we truly know. And still, we keep counting, because in every speck of light lies a question older than humanity itself. How far does this go? When we talk about the observable universe, we are really talking about a horizon, a limit set not by the universe itself, but by time. Light travels at a finite speed, so we can only see as far as light has had time to reach us since the beginning, roughly 13.8 billion years ago. But because space has been expanding all that time, the most distant galaxies we can observe today are now about 46 billion light-years away. Beyond that, the universe continues, but its light will never reach us. There is no edge, no wall, no boundary where the cosmos stops, only a point beyond which we cannot look. Astronomers call it the cosmic horizon. It is the ultimate frontier of knowledge, not because there is nothing beyond it, but because there is everything beyond it. The unobservable universe may be hundreds, even thousands of times larger than the part we can see. Some cosmologists estimate it could contain more than a quadrillion galaxies, an expanse so vast that even our imagination begins to fail. To put it simply, everything we know, all the stars, planets, nebulae, and galaxies we have ever photographed, could be just a single bubble floating in an ocean of countless others. If the observable universe were a drop of water, the unobservable universe would be the sea. And it keeps expanding faster than light, pulling those distant galaxies forever out of reach. This expansion is not like an explosion from a central point. It is space itself stretching. Every region of the universe sees every other region moving away. There is no center, no up or down. The universe is expanding everywhere at once, and that means every observer, anywhere, would see the same thing: galaxies racing away, their light stretched into red. As space expands, their light weakens, fades, and vanishes into the infrared abyss. The further we look, the more of the past we see, but there comes a distance so great that we cannot see at all. Beyond that, the galaxies are invisible, but they are still there, forming, colliding, dying, just as they do here. Some scientists describe this unseen realm as the cosmic wilderness, a place forever disconnected from us. We will never visit it, never detect it, never even know what galaxies dwell there. And yet, their gravity still tugs on the universe we inhabit. Their existence is written in the patterns of the cosmic microwave background, in the subtle ripples of temperature left over from the Big Bang. They are ghosts in the data, proof that the universe we see is only a small fragment of the whole. This realization forces us to rethink what reality even means. If most of the universe lies beyond observation, then the cosmos we can measure is just a tiny sample, perhaps not even typical. Our local patch of galaxies might be an anomaly, a rare bubble with its own unique structure, while beyond our horizon, other regions could look entirely different. Maybe they contain more dark matter, or fewer stars, or no galaxies at all. We will never know. It is humbling to realize that we live in a universe where most of existence is permanently hidden. The galaxies we can see are like the bright cities on a vast, unlit continent, illuminated islands surrounded by an ocean of darkness. We map what we can, but the horizon always retreats, teasing us with its silence. And yet, that silence is beautiful, because it reminds us that mystery is not an obstacle. It is the source of wonder itself. We may never see beyond the cosmic horizon, But that does not mean we are alone. It means we are part of something larger than we can ever comprehend. If we could step back far enough, so far that the entire observable universe fit into a single view, we would see something extraordinary. The galaxies are not scattered at random. They form a vast, interconnected structure, like threads in a cosmic web. This web is the architecture of the universe, a frozen map of gravity sculpted over billions of years. It stretches across hundreds of millions of light-years, with dense clusters of galaxies connected by filaments of dark matter and gas, separated by immense cosmic voids, regions so empty that they contain almost nothing at all. The result is breathtaking, an invisible skeleton of the cosmos, where gravity and time have woven galaxies together into a pattern that resembles neurons in a cosmic brain. This grand design did not appear instantly. After the Big Bang, the universe was almost perfectly uniform. Tiny fluctuations in density, no bigger than 1 part in 100,000, dotted the primordial plasma. Over billions of years, gravity amplified those fluctuations, drawing matter into filaments and knots, leaving behind vast, empty regions. The first galaxies formed at the intersections, where matter was densest. As time passed, they merged into clusters, and those clusters into superclusters, creating the largest structures in existence. Each filament is like a river of galaxies, flowing toward gravitational wells billions of light-years across. Some of these structures defy belief. The Sloan Great Wall, discovered in 2003, stretches 1.4 billion light-years long. The Hercules Corona Borealis Great Wall is even larger, so massive it may span 10 billion light-years, challenging our understanding of cosmic uniformity. By comparison, our own local group of galaxies, which includes the Milky Way and Andromeda, is barely a pebble in this cosmic landscape. These colossal formations remind us that the universe is not a quiet place. It is a masterpiece of motion, a living structure still evolving, expanding, and reshaping itself under the invisible hand of gravity. The cosmic web is more than a visual wonder. It is the backbone of cosmic evolution. Along its filaments, gas flows into galaxies, feeding star formation and sustaining the luminous spiral arms we see through telescopes. Galaxies, in turn, release energy, radiation, and heavy elements back into the web, enriching the intergalactic medium and driving new cycles of creation. Everything in the universe is connected by these threads, even across unimaginable distances. When a galaxy moves, it sends a ripple through the web, a subtle gravitational echo that travels for billions of years. And yet, for all its vastness, the web has a rhythm, a pattern of repetition and symmetry that feels almost alive. Astronomers describe it as a cosmic foam, with galaxies clumped along the edges of empty bubbles. The voids, hundreds of millions of light-years wide, are the silent spaces between the chords of the universe's music. In Nion's, those dark expanses, there are almost no galaxies, no stars, no light, just the faint whisper of dark matter and the residual glow of the cosmic microwave background. It is the closest thing we have to pure nothingness, and even that nothingness vibrates with potential. When you zoom out far enough, the universe looks less like a scattering of lights and more like a single, coherent organism. Threads, nodes, and flows of matter tracing an elegant geometry. It is tempting to think of it as a kind of cosmic mind, with galaxies acting like neurons firing across unimaginable distances. Perhaps that is poetic, but there is a truth in it. The universe is structured, ordered, and aware in its own mathematical way. Its patterns reflect the balance between chaos and harmony, randomness, and law. If galaxies are the letters of the cosmic story, then the web is the language that binds them. And just as every word has meaning, every filament tells part of the tale of creation. But for all its grandeur, the web is not complete. Something unseen holds it together, something we cannot touch or see, but can feel in the way galaxies move. To understand why this structure exists, we must look into the invisible, into the dark scaffolding beneath the light, the realm of dark matter and dark energy, the silent forces shaping the universe itself. For all the brilliance we see in the galaxies, the radiant spirals, the blazing cores, the rivers of stars streaming across the cosmic web, most of the universe is invisible. The light, magnificent as it is, accounts for almost nothing. Everything we know, everything we have ever observed, makes up less than 5% of reality. The rest is dark, an unseen mass that bends light, shapes galaxies, and drives the expansion of the cosmos itself. It is a universe built not on what shines, but on what hides. This hidden scaffolding is called dark matter. It does not emit, absorb, or reflect light. It passes through ordinary matter like a ghost, leaving only gravity as its fingerprint. Astronomers first discovered its presence not by seeing it, but by noticing its effects. In the 1930s, Fritz Zwicky studied galaxies in the Coma cluster and found they were moving far too fast to be held together by visible matter alone. Without some unseen mass adding gravitational glue, the cluster should have flown apart. Later, Vera Rubin measured the rotation curves of spiral galaxies and found something even stranger. The stars at the outer edges were orbiting at the same speed as those near the center. That defied the laws of motion unless each galaxy was surrounded by a massive, invisible halo. That halo, we now know, is dark matter, a cosmic cocoon holding the visible universe in place. Today, simulations of the universe depend on it. Without dark matter, galaxies would never have formed. After the Big Bang, ordinary matter was too hot and energetic to clump together on its own. Dark matter, immune to light and radiation, began collapsing under gravity, forming invisible wells where gas could cool and stars could be born. It is the silent architect of structure, the frame around which all visible creation was built. Every spiral arm, every star cluster, every galaxy we can see is merely a trace of the shadow beneath it. And yet, even dark matter is only part of the mystery. In the late 1990s, scientists studying distant supernovae made a discovery that shattered cosmology once again. They found that the universe's expansion was not slowing down under gravity. It was speeding up. Something unseen, stronger than gravity, was pushing galaxies apart. They called it dark energy. Its nature is still unknown. It might be a property of space itself, a kind of cosmic pressure woven into the fabric of reality. Whatever it is, it now dominates the universe, driving it to expand faster with every passing moment. Together, dark matter and dark energy make up 95% of everything. The visible galaxies, the stars, the planets, the nebulae, all of it, the entire spectacle of the night sky, is just a faint trace floating in a vast ocean of the unseen. We are living in a universe made mostly of ghosts. The irony is profound. The more we learn, the more we realize how little we actually know. Physicists are still searching for dark matter's true identity. It could be exotic particles, primordial black holes, or something we have not yet imagined. Deep underground, detectors wait in silence for the faintest hint of a passing dark matter particle. Particle accelerators crash protons together, hoping to reveal the unseen. So far, nothing. It remains a whisper in gravity, a mystery wrapped around every galaxy. But its influence is undeniable. Without it, the universe would collapse into chaos, or never have formed at all. This invisible 95% gives the cosmos its structure, its expansion, and ultimately, its destiny. Dark energy will determine the universe's fate. If it remains constant, galaxies will drift apart until everyone becomes isolated in an endless void. If it grows stronger, the expansion could accelerate so violently that even atoms are torn apart, a future some call the Big Rip. Either way, the visible universe is fading. The galaxies we see today are like candles flickering against an ever-darkening sky. Yet within that darkness lies the greatest mystery of all, the invisible forces that created everything we love, everything we fear, and everything we have yet to understand. The more we look into the dark, the more it seems that the universe itself is asking us to imagine, to see not with our eyes, but with our minds. Because the answers we seek are not in the light, but in the shadow that surrounds it. When we gaze at distant galaxies, we are not just looking across space, we are looking through time. Every photon that reaches our eyes began its journey billions of years ago, carrying the story of a universe still forming itself. The farther we look, the younger the cosmos becomes, until we arrive at its infancy, a time when galaxies were newborn, chaotic, and raw. In a sense, telescopes are not instruments of sight, they are time machines. Each image is a fossil of light, preserving a moment that no longer exists. The Hubble Space Telescope gave us our first glimpses of that ancient universe, but it was the James Webb Space Telescope that truly opened the door. Its infrared vision allows it to see light so old and stretched by cosmic expansion that it has shifted far beyond visible wavelengths. Through Webb's eyes, we are seeing galaxies that formed just 200 million years after the Big Bang, mere instants on cosmic scales after creation began. Some of these galaxies, like JD's GS Z13-0 and Sears 93316, exist at redshifts greater than 13, meaning their light has been traveling toward us for over 13.5 billion years. When that light began its journey, there was no Earth, no Sun, not even the Milky Way. We are looking at the first sparks of structure, the earliest islands of stars illuminating the darkness of the cosmic dawn. What Webb has revealed is astonishing. We expected to find small, primitive galaxies, fragile and dim. Instead, we found giants, massive, complex systems already filled with mature stars, swirling disks, and heavy elements. It was as if the universe had built its masterpieces far faster than we thought possible. These findings have forced astronomers to question the foundations of cosmic evolution. How could galaxies so large exist so soon after the Big Bang? Are our models of star formation incomplete? Is there new physics at play, something beyond what we understand about dark matter, inflation, or gravity itself? In these earliest galaxies, we see the first seeds of everything that would come after. Their stars forged the elements that would one day make planets, oceans, and life. Their supernovae scattered metals into the cosmic web, enriching the gas that formed the next generation of stars. Over billions of years, these tiny, distant galaxies merged and grew, becoming the spirals and ellipticals we see today. Every galaxy in the modern universe, including our own, carries the fingerprints of those first celestial ancestors. But there is a strange paradox hidden in this light. The farther we look, the more the past begins to resemble the present. Galaxies form patterns, clusters, and behaviors that echo across time. The universe is not random. It is recursive, repeating its shapes at every scale, from the earliest structures to the largest superclusters. It is as if the cosmos were writing the same story again and again, only with different characters and new endings. Every photon captured by our telescopes is a message from the deep past. Some of it began its journey when life on Earth was still microscopic. Some left its galaxy when dinosaurs roamed our planet. And some, most, set out long before there was even a planet to receive it. When you stare at an image of a distant galaxy, you are looking at an echo from before your species, before your world, before time as we know it. The galaxies we see today are not simply objects of study. They are memories, preserved in light. And when we gather them, we are piecing together the autobiography of the universe itself. From the first flicker of light to the spirals that now shine overhead, every galaxy is a chapter in the same vast story, a story still unfolding, and one that we, impossibly, are a part of. But every story has an ending, and the galaxies, too, are not eternal. To understand the full arc of the cosmos, we must face the question few dare to ask. What happens when the galaxies themselves begin to die? The galaxies we see blazing across the night sky are not immortal. They are temporary arrangements of matter, brief flashes of structure in an ever-expanding universe. Every one of them, no matter how vast, how ancient, or how beautiful, will one day fade. Star by star, they exhaust their fuel, dimming like candles in an endless night. What we call eternity is, for the cosmos, just another fleeting moment. Even now, some galaxies are already dying. Astronomers call them red and dead ellipticals, giant, smooth spheres of aging stars. Once they burned with a newborn light, but their gas is gone, their star-forming nurseries empty. No more new suns will ever ignite. Over billions of years, spirals like our Milky Way will meet the same fate. Collisions and mergers will consume their shapes, transforming them into quiet ellipses of fading light. The great cosmic engines will go still. Our own story is already written in that pattern. In roughly 4 billion years, the Milky Way and Andromeda will collide in a slow, magnificent dance. Their spiral arms will stretch and twist, stars flung into long tidal streams. Clouds of gas will ignite in brilliant bursts of creation, even as others are torn apart. At the center, the two supermassive black holes will spiral toward each other, merging in a flash of gravitational waves that ripples through the fabric of space-time. What remains will be a single, enormous elliptical galaxy, Milkomeda, glowing faintly against a darkening sky. It will mark both the end of one chapter and the beginning of another, the long decline. Over trillions of years, the galaxies will run out of gas entirely. The blue light of young stars will vanish, replaced by the faint red glow of ancient dwarfs. Eventually, even those will cool and die, leaving behind black dwarfs, neutron stars, and black holes. Collisions will become rare. The cosmic web itself will stretch as expansion accelerates, pulling the remaining galaxies farther and farther apart. One by one, they will disappear beyond each other's horizons, their light redshifted until it fades completely. The night sky of the far future will be empty. No galaxies, no stars, only darkness and the faint whisper of background radiation. This is the heat death of the universe, a slow and silent ending where all energy is evenly spread and nothing more can happen. Entropy reaches its peak, motion stops. Time, in a sense, ceases to have meaning. The cosmos becomes a frozen sea of thin, cold particles drifting through eternal night. Yet even that ending is not a tragedy. It is the natural consequence of creation itself. The same laws that gave birth to galaxies also demand their death. From that perspective, the fading of light is not destruction, it is fulfillment. And within that truth lies something profound. The fact that galaxies exist at all, that they have lived long enough to create stars, planets, and consciousness, means we inhabit an extraordinarily rare window in cosmic history, a moment when the universe is still bright enough to see itself. We are beings of temporary light, alive in the age of illumination. Every time we look up, we are seeing the cosmos before it goes dark, witnessing the last great fireworks before the quiet. The death of galaxies, then, is not just a story of loss. It is a reminder of how precious this moment is. We live in the universe's golden hour, when the stars still burn and the galaxies still sing. And though one day their voices will fade, the fact that we can hear them now, across billions of years, means that the universe, for a time, became aware of its own beauty. And so, after all the light, all the structure, and all the wonder, we arrive back at the question that began this journey. How many galaxies are there, and what is truly out there? The honest answer is both humbling and profound. We will never know. Not because the universe hides from us out of cruelty, but because its immensity exceeds the reach of any instrument, any species, any future civilization. The cosmos is not designed to be measured. It is designed to be experienced, one moment of light at a time. Every number we propose, 200 billion, 2 trillion, perhaps infinitely more, is not a final truth, but a reflection of how small our window is. Beyond the limits of observation, galaxies continue to form, collide, and dissolve, unseen and uncounted. The universe is still creating even as it fades. Somewhere, far beyond our cosmic horizon, another civilization might be looking up at their own night sky, wondering the same thing we do now, asking how many galaxies exist beyond their reach. The thought alone connects us, a shared act of curiosity bridging unimaginable distances. What we have learned from a century of discovery is this: galaxies are not merely collections of stars, they are chapters of time, structures through which the universe expresses itself. They are living archives, each one preserving the memory of creation. And by studying them, by daring to look farther and deeper into the dark, we are not only uncovering the history of the cosmos, we are uncovering the story of ourselves. Because somewhere, amid the endless web of galaxies, one small world looked up, saw the light, and began to ask why. We are that question made conscious, the universe's attempt to understand its own reflection. The galaxies are not separate from us. They are our ancestors, our origins written in starlight. The atoms in our bodies were born in their hearts. The calcium in our bones, the oxygen in our lungs, the iron in our blood, all forged in the furnaces of ancient suns that once lived, died, and gave their ashes back to the void. We are, quite literally, the universe remembering itself. One day, the stars will go dark, the galaxies will drift apart, and the story will grow silent. But this brief moment, when galaxies shine, when consciousness blooms, when we can still look up and wonder, will always have existed. That fact can never be erased. The light we see from the distant past is also the light we give back in awe and understanding. So, how many galaxies are there? More than we can count, more than we can ever imagine. And that is precisely what makes the universe beautiful, that its mystery endures, infinite and alive. Until the next question,